Move that. All right. This is 2011, question 4. And my dog just sleep barked. It was really adorable. Okay. Part A, we need to find g of -3, but I first want to look carefully at how g is defined. I'm going to replace every x with that -3. And one important thing to notice is that the limits are in the opposite order as they normally are. So I want to go over to 0 and -3. So I've got x equals 0 and x equals -3. And it's looking at this, but it's looking backward on it. So it's actually going to be negative whatever that area is. So it's going to end up equaling -6. Let me try writing that better. And then minus the area, because again of this being backward order. Now the problem tells me that the graph of f consists of 2 quarter circles and 1 line segment. This is a quarter circle with a radius of 3. So the area of the circle is 1/4 of pi times 3 squared. So 9/4 pi. And that is g of -3. The next thing it's asking me to do is find g prime of x and then evaluate g prime of -3. I'm going to erase what I have for g of -3. Let me know if you need me to not erase. So taking the derivative of g of x, I first have the derivative of 2x, which is 2. Then I take the derivative of an integral. So that's the fundamental theorem of calculus. And I'm going from a constant to just the variable alone. And that means that the derivative of that integral is going to go straight to the integrand. Just going to be f of x using now the variable x. Then once I find that, I need to plug -3 in and figure out what that is equal to. So plugging -3 in, I get 2 plus f of 3. When I come back to look at the graph, I remind myself that this is the graph of f, and I need to know f of 3, so the y-coordinate, when x is 3. Thank you. You're right, f is -3. That's kind of important. Hello, Mr. Negative Sign. So then I'm looking at when x is -3, what is the y-coordinate? And the y-coordinate is 0. And that's all that there is to part A. So it's just 3 things. And honestly, they're only looking for the answers. So you don't have to worry too much about the work you show, but you do need to make sure that you designate, like, this is g prime, this is g prime of -3, that kind of thing. So moving on to B. Ooh, it's asking for an absolute maximum. But let's read it carefully. Get this out of the way. Are you okay? My dog was getting comfortable and it's making noise. Envying him tremendously right now. Just, I'm sleeping. This says determine the x coordinate of the point at which G has an absolute maximum. Now, because it says determine the x coordinate where it happens, you don't have to actually find the absolute maximum. You just need to justify the x coordinate that it occurs at. When I take a deeper look at what's going on with this function, when I look at, I'm trying to say, I'm determining the x coordinate which G has an absolute maximum. I need to find the critical numbers of G. So that means I need to know what makes the derivative of G equal to 0 or undefined. Here is the derivative of G, and I need to know what makes it equal to 0. So when I look at that equation, I realize that my critical number is actually going to be the solution of when f of x is equal to -2. Now, f of x is equal to -2 at this x coordinate right here. And my derivative is going to be positive before that point and negative after that point. Because, again, the derivative is 2 plus f of x. So before I reach this point, f of x is larger than -2. And after that point, f of x is smaller than -2. Now, with there being only one critical number, let me make sure this is very, very clear. What I'm about to tell you, you can only use it if there is one critical number only. If you have more than one critical number, what I'm about to do is not sufficient. Because they didn't want me to say the actual absolute, I forget, minimum, maximum, I just need to justify where it happens. I don't need to make a table showing this is my y value for this endpoint, this is my y value for that endpoint, this is my y value for the critical number. With one critical number, I can say that G prime, let me make sure I'm naming the right function, yes. G prime is positive over the interval. What can't happen on an endpoint? Absolute max can happen on an endpoint. But with this, when you look at it, because the slope is first positive and then it is negative, the absolute maximum has to be at the critical number. So only if you are in this situation or if you are in the opposite situation, you can explain that you have an absolute minimum at the critical number. Or if you have a critical number and the slope is positive followed by positive, then you know that you have an absolute maximum at the right endpoint and an absolute minimum at the left endpoint. And you don't need to actually find the y values to justify. You just need to make sure that you express for the domain of the function where the derivative is positive and negative. So my function begins at -4. As I go from -4 to this critical number, now I actually need to be careful about finding this critical number and make sure that I have the right x coordinate. I have to do that based on the equation of this line. If I look at the line, I can see that it has a slope of, it goes down 6, right 3. So it has a slope of -2. and a y-intercept of positive 3. So the equation of this line is y equals, it starts at 3 and has a negative 2 slope. And this has to be the x-coordinate where the y is equal to negative 2. So I'm going to put negative 2 in for the y. And you need to make sure to solve that equation. It looks like it's 2.5, but you need to solve this equation to verify that it is 2.5. Now, I will tell you that if you assume it's 2.5 and you didn't really prove to yourself, you're still going to get the point. They're not looking, in this situation, they're not looking for you showing that you know how to get that. You don't have to show your algebra work, and that's algebra work. Then G, there we go. G prime happens to be a negative number as you go from 2.5 to the x-coordinate 3. This is justification for why G has an absolute maximum. At x equals 2.5 over the interval of negative 4 to 3. Because if I go further than that interval, there's no guarantee any longer because I don't have that information. And that would justify it. And do keep in mind, these problems are timed. If you sat around and found the value of G at negative 4 and found the value of G at 3 and found the value of G at the critical number 2.5, that could take you a lot of time. But you recognizing how the derivative is positive and then negative does not take nearly the same amount of time. And they're actually expecting you to look at it this way. You'll get full credit if you find the actual values and compare, but you're going to spend more time on it. And that might cause you to not be able to finish the exam. But let me tell you this, and this is very important. When you are going through a free response exam, there are going to be parts that you read over and you feel overwhelmed with. You want to make sure that the problems you know how to do, you slow down on and get them right, and you don't mess those up. Problems that look like they're going to take you a long time, skip over them temporarily, and if you have time, come back to them. But you want to be careful with your time. Very few people genuinely finish these free response problems in the amount of time. A lot of people give up in the amount of time. Yeah, but you could always spend more time and do better. There are very few people who genuinely don't need more time. Anyway, part C, here we are. Find all the values of x on the interval for which the graph of G has a point of inflection. I like to write down my reasoning that it's going to need before I find out the answer. Because by writing down the reasoning, I know what I need to go hunt for. If it wants me to justify a point of inflection for G, my reasoning can only be because G double prime changes sign. So I'm going to write that down. G double prime changes sign. Now, I don't have G double prime. I so far do have G prime. So I'm going to use that and take the derivative to get G double prime. Derivative of 2 is 0 plus, and then derivative of f of x is f prime of x. So now I know that I'm looking at f prime of x changing sign. I want to go to the graph and be very careful about who the graph is. The graph is for f, and I want to know if f prime goes through a sign change. Based on the graph, f prime will go through a sign change, excuse me, if f changes from increasing to decreasing or vice versa. So again, I'm going to look at the graph of f, and f prime is the slope of f. For f prime to change from either positive to negative or negative to positive means that the graph changes direction. So maybe I want to say graph of f changes direction. And just kind of get straight in my head what it is that I'm looking for on that graph. As you look at the graph, do you see where this graph changes the direction it is moving, or changes from increasing to decreasing or decreasing to increasing? With this being the graph of f, f prime is positive, undefined, and then f prime is negative. You don't need to express that f prime is undefined at x equals 0. What you do need to express is that f prime changes sign at x equals 0, which you can express in different ways. You can say that the graph of f changes direction. You can say f prime changes from increasing to decreasing. If you did a G double prime chart, you found this because we have positive going up, 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 negative going down, 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 down. And you can say because G double prime changes from positive to negative. So these are all legitimate reasons and ways to write it. And at that point, all you need to do is say that it has a point of inflection at x equals 0. And I'm just going to write P of I to shorthand it. And then your because is any one of these stars. All right. Then we're moving on to the next part. That was C. We're moving on to D. The first thing that D is asking me to do is find an average rate of change. Every time the word average shows up, I become very cautious to read it carefully and not make an assumption about which average formula I'm using, because there are two average formulas. There's the average rate of change, and then there's the average value. And I've found in reading College Board problems that sometimes they sneak the wording in a weird way with the way that the function is presented, where you might think you need to use one formula, but it's actually the other. So I always slow down. Find the average rate of change of f. If I'm finding average rate of change of f, if I know f, then I'm able to do f of b minus f of a over b minus a. And I'm pulling out the slope formula of change in y over change in x. Now I'm going to look and see, do I have the information I need to be able to say this? I have the graph of f. Am I going to be able to find the values of f at 3 and -4? And I can. So this formula will be the right way to go. You have to always look at how did they present the function, what information did they give in order to decide if you need to go this route. So you need to definitely show them that you know the average value formula that you are using with the numbers. So make sure to write down what I'm writing right now. Then I'm going over to the graph and I'm finding f of 3, and that's -3. And I'm finding f of -4, and that's -1. So -3 and -1. And that will be -3 plus 1, so -2. So -2/7. Period. It goes on and says, there is no point C between -4 and 3 for which f prime of C is equal to the average rate of change. Voila. Explain why this statement does not contradict the mean value theorem. You need to go back and remember, what is the mean value theorem? The mean value theorem says that you have to be dealing with a function that is continuous and differentiable. It has to be continuous over the closed interval. And in this case, that would be -4 to 3. And the function has to be differentiable over the open interval from -4 to 3. And the mean value theorem says if these two things are true, then you are guaranteed that there is some C between the -4 and the 3. There is at least one C such that the average rate of change, and I'm going to write it this way, f of 3 minus f of -4 is equal to the instantaneous rate of change. Now, what the problem said was that this isn't true. There is no C in this interval that is equal to the average rate of change. That means one of these two has to be untrue for some x in the interval. Now I'm going to go back to the graph of f. F is definitely continuous from beginning to end, but do you see that it's not differentiable right here? It's got an instantaneous change in slope where it skips over a bunch of slopes to go from its left side to its right side. It's a sharp turn in the graph. So for your explain why this statement does not contradict the mean value theorem, you need to say because f of x is not differentiable at x equals 0, and 0 is between -4 and 3. And that's the only thing you actually need to write. I said a lot more than you need to think through on this problem because I'm reviewing with you. And because I felt like you probably wanted to remember what was the mean value theorem anyways. But all you have to do on the EP exam is realize which of these two it contradicts, write it down, move on. And I'm going to stop recording this.